Hey everyone, and welcome back for another deep dive. We've got some pretty interesting stuff to get into today. All those like intriguing future events and phenomena, the kind of things that we'll miss and the ones that maybe we might get to experience. It's a really cool mix of stuff, actually. I was looking over the articles and research you sent.
Yeah, it's pretty fascinating, isn't it? I mean, we
Yeah.
spend so much time thinking about, the day-to-day, but when you start to think about this stuff,
Mm.
it really forces you to like step back and consider time in a totally different way.
Totally. It's funny. I was reading about this thing. Like, did you know that the year 6009 is going to be the first reversible year since 1961?
Mm.
You can like write it out, flip it upside down, and it's the same.
Wow.
I know it's like a tiny little quirk, but it kind of makes you realize, how much time is stretching out ahead of us and how little of it we actually get to see.
It really does. It's amazing to think about. And speaking of seeing things unfold over time, have you heard of this project in Germany? The time pyramid? So they're adding a layer of bricks every 10 years, and it won't even be finished until the year 3183.
Wow.
It just makes you think, I mean, why create something that won't be completed for over a millennium? It says a lot about how we think about time, doesn't
Yeah,
it?
it really does. It makes you think about long-term thinking, that's for sure. But on a kind of darker note, the Chernobyl exclusion zone is another example of how, our actions can have really long-lasting consequences.
Yeah, absolutely.
They say it won't be safe for people to live there again until the year 22,000. It's a long time.
That's a long echo. Really is sobering to think about. But maybe let's shift gears a bit for a second, talk about something a little more spectacular. Within the next million years, we're expecting to see not one, but two massive supernova events,
Yeah.
Betelgeuse and Edo Carinae, both much larger than our own sun.
So wait, these supernovae will be brighter than the moon?
Oh, yeah.
Visible even during the day. I'd hate to miss that.
Oh, absolutely. But a million years is a long time. Chances of us catching the show are, well, pretty slim, I'd say. But there's another cosmic event that's even further in the future, and it's even more mind-boggling. The Andromeda Galaxy Collision.
Okay, now this is where it gets really interesting to me because we're talking about two entire galaxies. Like they're on a collision course. It's like a slow motion, billion-year long cosmic train wreck.
That's a great way to put it. And so right now, Andromeda is just a faint little smudge in the night sky. But over billions of years, it's going to draw closer and closer. And eventually, it's going to become like a dominant feature in our sky. I mean, imagine stepping outside one night, billions of years from now, and seeing this massive, swirling galaxy right next to our own Milky Way.
Yeah, it's almost impossible to really picture, but then eventually they actually start to merge, don't they? I'm trying to picture what that would even look like. All the colors, the swirling gas and dust, the birth of new stars.
It's going to be an incredible light show, like cosmic tie-dye on a galactic scale. And eventually, those two galaxies are going to merge into one, forming a new galaxy that some are calling Milkdromeda.
A Milkdromeda. It's kind of a funny name for something so epic.
Yeah.
But it's kind of catchy, so it seems like future generations are in for quite a show. But this whole conversation has me thinking about the other side of things. Like, what about the things that they're going to miss? What wonders do we get to see now that won't be around in the distant future?
Well, that's a great question, and it really brings us back to that idea of the fleeting nature of things, even things that seem permanent, even
Yeah.
things like mountains and waterfalls. I mean, they're constantly changing, eroding away over time. Take Niagara Falls, for example. It's a breathtaking sight. But by the year 52,000, it's predicted to have eroded all the way back to Lake Erie.
No more Niagara Falls. I mean, it's hard to imagine. I remember visiting as a kid, feeling the mist on my face, hearing the roar of the water. It felt so powerful, so permanent.
And that's the thing, right? I mean, these things feel permanent to us because our lifespans are just so short compared to, the vast scales of geologic time.
Yeah.
Even Mount Rushmore. That's expected to erode away in about 7 million years. And even Saturn's rings, those beautiful swirling bands of ice and dust, are expected to disappear within the next 50 to 100 million years.
It really puts things into perspective, makes you realize we're just passing through, witnessing these wonders for like a brief moment in time.
Exactly. And it's not just the big physical things that will change.
Mm.
I mean, think about all the events that we miss out on experiencing firsthand because we just weren't alive yet.
Yeah, like none of us have any memory of our own conception or birth, even though those are like pretty important to say the least. It's like a universal FOMO, I guess.
It is. But here's what's so fascinating. We can still find ways to kind of connect with those moments. Like there's a website called When Was I Conceived?
Oh, yeah.
And it uses your birthday to tell you the approximate week of your conception, along with things like the top song and the top movie from that week.
Okay, that's pretty cool. I mean, it's not going to bring back any memories, but
Yeah.
it's a fun way to think about that time period, I guess. What was that other tool you mentioned? Something about a star calculator.
Yes. So this one lets you find a star that's as many light years away from Earth as you are old. And the really mind-blowing thing is that when you look at that star, you're seeing light that left it at the exact moment you were born.
Wait, so those photons, those little particles of light, have been traveling across the universe for my entire lifetime just to reach my eyes in this moment.
Yeah, exactly. It shows you the incredible connection we have to the universe, to events that happened long before we were even a thought. It's like we're looking back in time to the very moment you came into being.
That's a lot to process, but it is incredible when you think about it. Can you explain a little bit more about how those photons travel for millions of years? Like, where do they come from and how do they make such an epic journey?
Well, it all starts with the birth of a star. So stars, they form from these enormous clouds of gas and dust, and they collapse under their own gravity. And as this material collapses, it heats up, and eventually the core reaches a temperature and density where nuclear fusion can begin.
And when we talk about nuclear fusion, we're talking about like a lot of energy being released, right?
Oh, absolutely. Nuclear fusion, it powers the sun and all the other stars, and it's the fusion of hydrogen atoms into helium. And this reaction releases this incredible amount of energy in the form of light and heat.
So these photons are literally born from this incredibly powerful reaction happening in the heart of a star.
It is pretty wild when you think about it.
Yeah.
But the journey doesn't end there. A photon that's created in the core of a star has to fight its way out through these incredibly dense layers of gas. It gets constantly absorbed and re-emitted, bumping into other particles. It can take thousands, even millions of years for a photon to reach the surface of the star.
It sounds like a real struggle. Like, it's amazing that any of them make it out at all.
I know, it's incredible. But once they reach the surface, they're free to travel across space at the speed of light. But even at that speed, space is so vast that it can still take millions of years for a photon to reach another star system.
So these tiny particles are on an epic journey, from the fiery heart of a star to the vastness of space. But how do they actually end up reaching us here on Earth? It seems like the odds would be incredibly small.
You're right. It really is all about chance and timing. Out of the, trillions upon trillions of photons that are constantly streaming out from stars, only a tiny fraction will happen to be traveling in just the right direction to intersect with our planet.
It's like winning the cosmic lottery for a photon to actually reach Earth.
That's a great way to put it. And even then, most of those photons will interact with the Earth's atmosphere, getting scattered or absorbed. So only like a minuscule fraction of photons actually make it all the way to our eyes.
It's mind-boggling to think about, and yet it's happening all the time, like constantly. Every time we look up at the night sky, we're being bombarded by these ancient messengers from the distant past.
It's true. It really makes you realize that we're not just observers of the universe. We're participants in this grand cosmic dance, connected to everything around us by these tiny particles of light.
It really is a different way of looking at things, this whole conversation. But I have to admit, we've been focusing so much on these far future events, these timescales that are almost impossible to grasp. What about the more immediate future? Like, what can we expect to see in the next 100 years or so?
That's a great point. I mean, it's easy to get lost in, thinking about the vastness of time and space, but the next century is probably going to bring some pretty remarkable developments, too.
Oh, I'm sure. Like, what kind of changes? Flying cars?
Yeah.
Teleportation? Are we finally going to get those pizza-delivering drones everyone keeps talking about?
Well, maybe not teleporting pizzas just yet, but the next century will probably see some pretty big changes, especially in two key areas: artificial intelligence and biotechnology.
Okay, so AI and biotech. Well, let's start with AI. It seems like that's changing things so much already.
It really is. Think about how AI is already being used. Self-driving cars, personalized medicine. And that's just the start. In the next 100 years, AI is likely to become even more sophisticated, even more integrated into our lives.
It's kind of exciting to think about the possibilities, but honestly, it's a little unnerving too. You know all those sci-fi stories about robots taking over? Are we heading for like a dystopian future?
I understand the concern, and it's important to be aware of the potential downsides as AI gets more powerful. But AI is a tool, and like any tool, it can be used for good or bad. It's up to us to guide its development, make sure it's used responsibly, ethically.
Okay, that's reassuring. So AI is one big area. What about biotechnology? What kind of things are we likely to see there?
Biotechnology is another field that's ready for explosive growth in the next few decades. We're seeing incredible things with gene editing, personalized medicine tailored to your DNA, even research into extending human
On
lifespans.
extending lifespans. So are we talking like immortality here? I don't know if I'm ready to live forever.
Immortality is still science fiction, but the potential for significantly longer, healthier lives is becoming more real. I mean, imagine a world where people routinely live to be 120, 150, even older. What would that mean for our society, our relationships, our understanding of what it means to be human?
Wow, that's a lot to think about. It would change everything.
It would. And these are just two of the many areas where we're likely to see really big changes in the next century. It's a time of incredible potential. The line between science fiction and reality is getting blurrier and blurrier all the time.
It's exciting and kind of overwhelming at the same time. It really makes you realize that we're living at a pivotal moment in history.
We are. And it's important to remember that we're not just watching these changes happen, we're helping shape the future. The decisions we make today will have a ripple effect for generations to come.
Well, we've covered a lot of ground today, from the mind-boggling timescales of the universe to the potential for really incredible changes in the next century. It's been a real journey.
It really has. And if there's one thing I hope you'll take away from this, it's this. Time is precious. Whether we're talking about billions of years or just a few decades, it's important to make the most of the time we have.
Absolutely. Cherish the present moment. Be kind to one another. Never stop exploring and learning. And as we've learned today, even though future generations will get to see some amazing things they won't have you have your own unique perspective, your own set of experiences, and that's something to celebrate.
Well said. So next time you look up at the night sky, remember all the amazing things we talked about. The distant galaxies, the journeys of photons, the incredible possibilities of the future, and then go out there and make your own mark on the universe.
That's it for this deep dive. Thanks for joining us. Until next time, keep looking up, keep asking questions, and keep exploring.